Hello students, in this slide we'll study about images made by convex mirror and the sign conventions in mirrors. Let us first draw the convex mirror. The black one is a reflecting surface and the pink one is a non-reflecting surface. Pole, focus and the center of curvature. Now I have placed the object, as you can see, away from the mirror, and the object is at infinity, which is represented by the dotted lines. Now we'll take another ray again at infinity, from coming from the infinity. Now you can see both the rays are parallel to the principal axis. So let us revise how they behave. Let us draw another diagram for the same and the important points. The object is at infinity, represented by the dotted lines, and when it reflects, it will appear that it is coming from the focus. That is how the incident rays which are parallel to the principal axis behave. Okay, now let us take the second ray, and it also behaves in the same way. When we extend the reflected ray, they appear to be meeting at focus, so our image will be formed here. Now let us check in sentences. Properties of the image formed. Position, it is at the focus behind the mirror, and size is point sized because these rays are meeting at a point, so point sized and highly diminished. The nature is virtual. And let us take the next case. I have drawn the convex mirror, important points, and you can see that now the object is between the pole and the infinity. Infinity we don't know, so it is at some measurable distance. So it is between infinity and the pole. Let us draw the rays that we are going to consider, and here comes the next diagram which will show us the reflected rays. Now important points: pole, focus and center of curvature, and I place the object between pole and infinity. First ray is parallel to the principal axis, so it will be appearing to be reflected from the focus. Let us check. Yes, now this is a reflected ray. Let us trace it back, and it appears to be coming from the focus. Let us take the second ray, because it is important to have a image formed when there are two rays at least. So you can see this ray, second ray, is obliquely incident on the pole, and then it is getting reflected back with some angle, same angle, because it has to follow the laws of reflection. And these two rays, reflected rays, when extended, they meet behind the mirror between the pole and the focus. So this is where the image will be formed. Let us check this out. Okay, now let us draw another case. You can see the convex mirror being drawn. I've drawn the pole, the focus and the center of curvature. Now I will take the ray, first ray parallel to the principal axis. It gets reflected and it appears to be coming from the focus. Then we have drawn a ray which is appearing to be coming from, or is appearing to reach, the center of curvature. It goes in that way. Now let us check how it will get reflected. It will, from the center of curvature, it will get reflected in the same way. So let us retrace the reflected ray. You can see that the reflected ray meets at this point. So here the image will be formed. Let us check. Yes, here. Now both the rays, both the cases, you can see the images formed between P and F. So let us start finding out the characters. The position is between P and F. Size is diminished in both the cases, and nature is virtual and erect. Yes. Now if you try to keep a screen also at the back of the mirror, you will never get this image. So it is virtual. And one more way by which you can say that it is virtual, because these rays are not actually meeting. We are imagining that they are meeting on their extension of the reflected rays. That is why it is virtual image. Let us see the next part, where we are going to study about the sign conventions. Now I am drawing the convex mirror, and with respect to this convex mirror, I have drawn a uh, you can say x-axis and y-axis. So it is, we have drawn the four quadrants. Okay, and this is towards the left of the mirror and this is towards the right of the mirror. Now the important points P, F and C. Then I have kept the object here. The object should always be placed towards the left of the mirror, whether it is concave or convex. That is one of the conventions used. First quadrant, second quadrant, third quadrant and fourth quadrant. Okay, now you can see this distance. It is from the pole to the object. So this distance is called as image distance and represented by the letter U. And then this distance between the pole and the focus is called as small f, that is focal length. Okay, now let us, this is the convex mirror. Now let us go to the concave mirror. Again the quadrants are drawn and I'm drawing now a concave mirror. You can see the reflecting surface is curved inwards. Non-reflecting surface left, this is towards the left side of the pole and this is the right side. Okay, now let us mark the important points and you can see the object is placed to the left of the reflecting surface, to the mirror, and this distance of the mirror and the object, between the mirror and the object, is called as image distance, represented by letter U. And the distance between the focus and the pole is called as the focal length, represented by small letter f. Now these are the conventions that we use. Now P is taken, as in maths we have origin as O, same way here P will be taken as the origin of the distances. So this is the place from where we start measuring the distances. And for measuring the distance you have to have the second point also. So what is that? The measured distances measured along the direction of the incident ray are positive. So you have to measure the distance along the incident ray. If you are going along with the incident ray, you are going in the positive direction. Okay, so if you are moving from left to right, you are moving to the positive direction. If you are going opposite to the incident ray, it will be labeled as negative. Okay, next we have whatever is above the principal axis, it will be positive. If you have any image which is in the opposite direction, then it will be called as negative. That will be measured as negative. Again, I draw the same diagrams, whatever we have done in the previous slide, so that you understand it a little better, and then I'm going to put whatever we have learned in form of a table. Let us first draw the concave and the convex mirror. Already done, repeated the images that we had in the previous slide. Now this is the table. Now by looking at these and whatever has been told earlier, let us sum up in the form of a table. Now you can see that for concave mirror, the U is always negative, and for convex mirror also U is always negative, because you are measuring this distance from pole and to the object. That is why it is negative. If you were measuring in this direction, it would have been positive, but it is not so. So U is always the object distance is always negative. So U is always negative, whatever may be the mirror. Now next, V, very important. V is image distance. So image distance for real image. Real image is formed in case of concave mirror only, and it will be in front of the mirror. So here, okay, so it is towards the left of the pole, in the opposite direction of the incident ray, so it is always negative. And convex mirror does not form any real image, so I have written Na. Then virtual, if image is formed virtual, that is behind the mirror, so if it is formed behind the mirror, then it is in the same direction of the incident ray, so it is positive. both the cases. Okay, then F, focal length. Here you can see focal length is in, if you measure from pole, it is in the same direction as incident ray, so it is positive. For convex mirror, for concave mirror, it is always negative. Why? Because it is moving in this direction from pole, it is in the opposite direction of the incident ray, so negative. Whatever is the sign for F, same will be for R, because the relation is R is equal to 2F. Then height of the object, always positive, because object हम हमेशा principal axis के ऊपर रखते हैं. Next, height of the image. If you have a erect image, that is virtual, then it will be positive. If you have a real image, then it will be inverted. That is, it will be below the principal axis. As a result, it will be negative. For convex mirror, you don't have real images, so Na is written. Okay, I hope it is. Now let us sum up here with mirror formula. Now mirror formula is given by 1 by f is equal to 1 by v plus 1 by u. Image distance, then object distance and the focal length. Let us sum it here. What these letters mean, what these alphabets stand for. Please remember them, and please remember the signs also. Very important for us to remember. Now if I solve this, this will be the way to solve it. Okay, you can, whenever you get values, you should utilize these steps to solve it. And this is the reciprocal, and here this is the focal length. Okay, so you will have to form the reciprocal, and you should remember to do this step, otherwise you may have miscalculations at the end. Now points to always remember. See, as we have told, u is always negative. The reasons are given here, and then f, that is a focal length, is always positive for the convex mirror, because this is a convex mirror and focus will be behind the mirror. And for concave mirror, it is always negative, because focus is always towards this side. It is always to the opposite direction of the incident ray. So reasons are written here. Please go through them. Where linear magnification. Linear magnification means how the image is enlarged or diminished when compared to the object, and it is given by the formula m is equal to h dash by h. What is this h dash? Let us check out. It is height of the image formed and divided by height of the object. So basically it will be a ratio, hence it will not have any units. There is another formula. Suppose h dash and h heights are not given, then you can utilize the image distance and the object distance. But while solving, sign convention has to be kept in mind. Okay, so this is what terminology stands for, and what you have to remember every time. If you have negative m as answer, then the image is a real image. If you have positive m, then it means